Okay, what I wanted to do is prove something, a result that is will be very useful for working out a number of problems that we're going to be looking at. And I guess we can call this the chord tangent theorem. I don't. I'm sure it has an official name, and I don't know exactly what that official name is. But chord tangent theorem. We have a circle. We have the tangent to the circle at right here. This is the tangent. We have a chord right here. Both the chord and the tangent are in red. And there is something we can say about what this angle C is, the angle between the chord and the tangent, in relation to the central angle that's spanned by the chord. So let's look at this. The circle has a center marked at 0 here, circle 0. These then are two radii coming out from the center of the circle. Because these two radii are equal, we can say that this triangle here, this triangle with the vertex at the center and at the ends of the two radii, that this triangle is an isosceles triangle because this side is equal to that side. So that means that both of these angles here are the same, and I'll call those angles B. Okay, angle A is the center right here, is the central angle spanned by the chord. Okay, now let's see what we can say about angle C here. We know that the sum of the three angles that are interior to the triangle is 180 degrees. So we can say that A plus B is equal to 180 degrees. This angle plus that angle plus that angle. We also know that if this is a tangent, that the angle between the radius and the tangent is 90 degrees. So we can say this angle right here is 90 degrees. So we can say B plus C is 90 degrees. I multiply this whole thing by 2 here. So 2 times B plus C must equal 2 times 90, or 180. So I multiply that through, and I have then this expression right here, that 2B plus 2C is equal to 180. And then I have had this expression from a minute ago, that A plus 2B is equal to 180. So I can take this expression up here, and I can subtract it from this expression down here. So subtract this from that. Okay, so that's 2B plus 2C equal to 180. And then I'm subtracting 2B, oops, sorry, writing that over again. I'm subtracting from that A plus 2B equal to 180. Okay, so I'm subtracting this, and then I'm subtracting this from that. So if I do that, I get 2B minus 2B. Those two cancel. I get 2C minus A. And then when I subtract 180 from 180 there, I get 0. So I get this expression, which tells me that 2C is equal to A. So in other words, this angle right in here between the chord and the tangent is half this angle here, which is the central angle spanned by the chord, or this angle is twice this angle, either way. So that's a result that we'll be using several times to try to solve problems, and I thought it was important enough to prove it. Okay, next time.